mission 1, what are we doing? Alright, each one of you write down what are we doing. Write a statement, okay? Just don't write one word, write a statement, write an answer. What are we doing with mission 1? What is mission 1?
Dedicated communication.
You need more time? You're done. You guys need more time? 2 more minutes? Don't copy from your neighbors. Alright, it seems like most of you are done. Most of you are done? Okay, let's start discussing. So now that you've had a chance to answer these 3 questions for all the 4 missions, let's prioritize these missions. So the priorities will be 1, 2, 3, 4. Okay. What priority would you give this one?
First
How many first priority? Okay, so 1. This is the first priority. This is the first priority mission. How many are there? 5, 3 professors here, and another 5. So let's say about 18. Okay. 18 say this is the first priority. This one, how many of you all think this is the first priority? Second priority.
No, for second we are raising the.
Oh, that was also the second one.
Yeah.
Okay, this is the first priority.
No. That is first. This is second.
Okay.
That is our.
This is so we have. Huh? So we have around. Raise your hands again. We have probably around 25, 30 people, I'm guessing. Okay, so about 28 people. How about this one? About 22, 20 people. I'm just guessing, okay? So please bear with me. For this one, It's about 14 or 15 people. Okay. Alright. Now let's take the votes. You want to take a vote? How many vote for this? Now, voting in priority is different. Okay. We haven't analyzed the first, second, third, fourth priority. Now, vote for this. Now, you get only one vote. You have to choose only one of them. You cannot choose two. How many vote for this?
Other than those 18 or everybody?
Everybody. How many vote for this as SIT mission? I'm going to count, okay? So 1, 2, 3, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21. Okay, 21 votes, okay? So they discussed that they are going to vote for this. All 5 of you discussed that you're going to vote for this. But that is not allowed, okay? Alright, how many vote for this?
Allah, this is overlapping votes.
It's only one vote because we have to take the next one we can fly.
Very good.
Raise your hand. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 24, 25, 31. About okay. So this one now there are 21 votes here, there are 34 votes here. So obviously this cannot be. How many votes are here? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How was this one?
Total, I am counting total.
This is actually an interesting experiment. You know what to do?
We want, but it is
So what we'll do is, I would actually suggest that this one, take it up, just study the feasibility of doing this experiment.
Because we cannot create the experimental satellite, it becomes bulky.
What we can do is, if we look at chamber, a small chamber, which you can like a incubation chamber, small incubation chamber with food, oxygen, and all those things.
And then we have to preserve, and then there are a lot of issues. And then biotech, maybe biotech students are
Yeah,
also.
maybe this is just
More expensive.
yeah, just look at this. Yeah, it could get more expensive just because you have to put all the oxygen, the food, and figure out how to do the mechanism.
Size also.
So it seems like this is
That
the
is
first priority. Okay, so we'll go with this mission. We'll discuss the remainder of this course in the context of this mission. Okay, is that okay with everyone?
Yes.
All right. So our mission is
Sir, for satellite also,
Hmm.
primary as well as secondary objective.
yes.
So like that, we can add
You can add something.
minimum 2 instead of 1. We can have 2.
So what we'll do is we're going to have this anyways.
Yeah.
because we're going to have communication system anyways, we can add a little bit of, let's say, sending some signal or something which is some chant or something like that. So when it is over, so instead of sending this thing, it will start with that chant.
Even in space, Siddhganga Institute of Technology, that chanting can happen.
Space. What is the limitation with? Can you send a chant in space?
No, sir. Sound.
Sound does not travel. Sound does not travel. The sound needs a medium. Okay.
That's a form of energy, it can disturb the satellite.
Yes.
Yeah. Vibration. So that anyway, mission 1 has to be integrated with the satellite.
By default, you'll have an onboard
And then
transponder.
this one and then maybe that one also we can try with some telescope or whatever is the low cost to monitor and then to capture picture and then
We will probably have, what we can do is we can look at having a camera and see whatever we can do with the camera.
even a 360-degree capture and then
Let's keep it simple. Then we can think about it. Because the more complex, the more moving parts, every moving part is a failure candidate. So we won't.
in space.
So now that we have now just keep this in mind, the life experiment. I'm especially requesting the faculty members explore this just out of curiosity or
Or this mission 4
Mhm.
can be simulated on ground itself by once we map that atmospheric conditions.
Right.
So why
The-
we have to take it to the there and see.
Even in a vacuum chamber, the inert environment is not there. In the sense,
Perfectly we cannot.
you cannot emulate that inert environment.
Cosmic radiations won't penetrate it.
Yes, something like that. Yes. So that environment when life started forming, that only exists in certain this thing. Because even when you put it in in a metal this thing, that metal has some this thing. So it is the environment is changed, and that is the reason.
So is there any way to measure cosmic energy?
Radiation, you can measure radiation.
Only radiation, but cosmic energy as a whole.
It's measured as radiation. So cosmic energy is measured as. So you can everything. But this is very important. Everything in space is either measured as. You can either think of that as vibrations, or you can think of that as electromagnetic radiation. So the electromagnetic spectrum, all that electromagnetic spectrum, you can emulate any activity of life. Energy itself is electromagnetic spectrum. So you can measure, if you have a wide spectrum or a wide frequency spectrometer, it can measure anything and everything. It's just that it's difficult to get a really wide spectrum spectrometer to function.
Almost infinite.
Yeah. So you just measure everything and anything that comes up. Okay. So we'll stick to this. Now you start applying what has been taught to you. So once we know this, where do we start?
Atmosphere.
Mission objective.
Yes, that's a good one. So remember the flow down? We discussed the flow down in class. So that is where, what was the first thing?
Identify.
The mission definition. Okay. So this is where once we have conceived our mission, we have decided what we want to do. We have to figure out how to do it, right? We have to figure out the system which is going to make this possible. So the mission definition is the first one. So mission definition, I'm going to give you something like on orbit evaluation of atmospheric models using a novel drag measurement suite, um, drag measurement. Okay, so this is, and again you can tweak this, or you can update this as you go along. But this will be the mission definition, okay, mission goal. So what is the mission goal? On orbit evaluation of atmospheric models using a novel. That this is important here. We have to design something novel. Okay. And that is our payload, the novel drag sensor suite. Got it? And a GPS receiver.
Here GPS plays only to locate the position of the
Right, and it will assist in orbital decay. So there are two models or two measurements which are giving you the same data or the same information. Okay, two sets of data which are trying to give you the same set of data, same set of information. So what is next?
Primary and secondary.
Objectives, right? So mission objectives. Now we talk about the PMO, primary mission objectives. Just give it a little bit of time, some time. Okay. How do you think are you going to measure drag? Think about the process. Because if you want to think about the objectives, think about the steps. What is a drag sensor? How will your drag sensor look like? What do you need to measure drag? You need a surface, right? You need a surface. And the sensors will be mounted on that surface, right? Now, you need as big a surface as possible, correct? This surface, can you launch a satellite with that surface already deployed? You cannot do that, right? That surface has to be
within the
satellite. It has to be stored. Okay. So the first objective would be designing would be think about on orbit. So we're looking at on orbit. So now think about on orbit. Now think about space. You're in space. What would be the first step in this thing? Deployment of the surface, right? So the first would be successful deployment of You understand what a gossamer is? You understand what a chute is? Chute? Parachute. It's essentially a circle. Okay. So we have Gauss number is nothing but a term for shoe. Okay. The first would be successful deployment of drag sensor shoot or Gauss number. Successful. Define successful or characterize successful for me. How are you going to make sure it is successful? Huh?
When the communication is installed with the satellite,
Mhm.
if we start receiving the data of the atmospheric drag through the sensors,
Hmm.
then we believe that there has been successful deployment as during deployment procedure.
But let's look at just this deployment itself. Because we are looking at these steps, primary objectives are different steps. Can you use, that is a good, very good approach. Can you think about a sensor which will validate the successful deployment of the shoot? Think about an umbrella, right? Now, can you design a sensor or can you implement a sensor which will tell you that the umbrella is deployed? What is a simple way of making sure umbrella opens? If, huh? That would be a little more challenging. So that you need a lot of, it is not going to immediately slow down, right? It's going to slow down over several orbits, several weeks for that matter, or even months. But can you, on board, can you deploy shoot? How would you, if somebody asks you, is the umbrella deployed? What will you do?
Batteries on. Solar sensor.
No, what will you do to make sure, just forget about space, now come back to ground. I'll tell you, deploy the umbrella, okay?
We need
You
force.
deploy the umbrella, how are you going to tell me if the umbrella is deployed or not? Huh? Huh?
If its volume has increased.
No, how are you going to make sure the umbrella is deployed? How are you going to make sure? Shadow. Simple way, how are you going to make sure? Huh? You're going to see it, right? Can you see that for an orbit? Can you make it, nobody's going to go there to see it, but camera, right? If you have a camera mounted there, the camera can take a picture of that deployment and send it back. So that can confirm the successful deployment, right? That's possible. That is one way of looking at it. I can use that same camera to capture pictures of SIT or Earth. You see that it's a dual purpose. So the dual purpose. A more complex, you can look at a more complex successful deployment mechanism would be, can you use, so let's say if you do this, have you tried to shake your cell phone? There are apps where you can shake your cell phone and it will do a task. Huh? No. Your cell phone. Think about it. So there are apps in your cell phone where does a cell phone sense this? Yes. So can you when this thing deployment happens, is there a jerk?
Yes.
Can you sense that jerk? How do you sense that jerk? Accelerometer. So you could, other way of looking at it is just employ accelerometers and probably gyros to figure out if it has deployed. If that jerk is there. If that jerk is there, and then you can say, look at the accelerometer data before deployment and after deployment. Figure out if there is a spike in acceleration in that direction. And you can say from the spike whether it has deployed or not. This is successful deployment. Okay. So this is how you validate. This is how you have to think about validating the primary mission objective. What is the second one? Measure drag as, what are we measuring drag as here? Strain. Okay. Are we going to send strain data or stress data to ground? Strain data. Why are you going to get? Why are you going to send stress data? You don't want to do anything on board unless it is required, absolutely required. You don't want to. Why do you don't want to do anything on board?
Because it increases complexity.
Computing, right? It uses computing and then it will require power, all that. So you don't want to send any data which is not required to be sent, or any extra computations, you don't want to do it on board. So we can just send you measure drag as strain and store. Now keep in mind, before you send it, when can you send it? Now you know the satellite is going to have a
Limited visibility.
limited time, right? Limited window. Are you going to do drag measurements only during that time?
No. All the
You're going to do it
All the
all throughout the orbit.
has to store.
So it has to store. So the first thing you're going to do is you're going to store that data, right? So measure drag as strain and store it on board. Okay. So this is the second primary mission objective. What is the third one?
transmit.
Yes. The final one is transmit. Now, what else are you going to store along with this data?
Position.
Position, orbital position. So you need the corresponding position. At that point only you need the position. You understand? That is very critical, right? Otherwise, if you're just going to send the data and not the position, you won't know. One, you cannot compare. The other thing is, you won't know where this drag measurement, in what position in orbit this drag measurement was made. You need to know that, right? For example, if it is a polar orbit, then it is, you know what a polar orbit is. The orbit is going to be around the poles, okay? So if you want to measure, this position would be very critical for figuring out where this drag is. The drag at the poles, it's not the same around this thing. So we need that corresponding position as well. Is this visible to you guys? All of you? I'll just write it here.
No issue.
So the second one is measure
Measure drag and strain.
measure strain and
Store it along with the position.
and corresponding
Position.
orbital position. And store it on board. Okay. This is, you want to suggest a name? Yes.
SIDS.
Yeah.
SIDS.
No, we will take some time
Okay.
and then
I'm just going to call it SID satellite, okay? SIDSat. What is SID? SIDSat.
SID.
SID. Why SID? Siddhiganga satellite. Okay. So take your time. Don't take your time for effort. Okay, you have to give it to me before the launch. After launch, you're trying to figure out what do you call it. Alright. So this is the second mission objective, or the second primary mission objective. The third one is transmit
The ground station.
successfully the data stored in TMO2 is primary mission objective 2. Okay? So the data stored in primary mission objective 2, you have to transmit it to SID ground station. Okay? Is there a way to validate this mission objective on board the satellite? Can you validate it somehow? Like what I'm saying is something like this.
Is there any data points already based on the magnetic field?
No, what I'm saying is you execute this measurement and storage. Is there some way of validating that? So let's look at this data only and say if it is validated or not. Or what we can do is when we get the data, we'll look at what is the other important parameter you're going to transmit along with these two. You always need a
No.
time. So time instance is the onboard the satellite clock, the time at which this was transmitted. So that way we can validate that whatever data was stored, whether it was corresponding to a particular time or not. Okay? Because the orbit is going to, as I told you, the orbit is going to repeat, right? It's going to do that. The orbital position is probably going to be the same for one or two. So if you do one set of measurements, two set of measurements, how do you distinguish those two? Time. So the time is important. Okay. So corresponding orbital position, time, and store it on. So the time associated time is also important. Okay.
No, can we
Sir,
take help of
Can't we relate time by position by knowing only position?
So if you do, so it's like orbit is going to keep doing the same thing, right?
Yes, but it decays then.
It is not going to decay as much as, not that fast. It's going to take its time to decay. It's going to stay, it is going to decay faster, but it is not going to decay. For example, the first and two orbit, first orbit, second orbit. The error in the GPS receiver might be big enough for you to not know which is which. So if you know the time, you know this is faster than this or this after it happened.
any other ground station help can be?
Yes, so you can avail, if it is a UHF VHF station, you can avail ground stations across the world. So if you tell them what frequency you're this thing, and if you give them the protocol which or the data this thing, they'll downlink the data and send it. A lot of the teams will do that. Okay.
Any private they will do this? Private or?
There are so the advantage of amateur band. So this is called the VHF is called the amateur band. There are organizations which do this as a service. AMSAT, for example. And there's AMSAT in India as well, amateur satellite. they have a network of stations. So if you tell them connect me with stations in this region, connect me with, we have launched a satellite. Many universities will be under that AMSAT network, and they'll just, if you give them the two TLEs, what are TLEs? Two line elements or the orbital elements. If you give them the TLEs, they'll do the tracking, and whenever it's on board there or on there, this thing, they'll downlink and send the data.
Some of the apps are also
Apps are available for tracking, but not so much for
lower.
downlinking. So here you're talking about a lot of people will know where your satellite is, but downlinking is you have to tell the frequency, and if there is any kind of encryption, you have to mention it. Okay. So transmit successfully the data stored in EO. Now, do you want any secondary mission objectives? So I heard somebody say temperature. That's an interesting discussion. Can you measure temperature in space? Of the space? How are you going to measure space temperature?
Radiation.
No,
Radiation. You could do that.
you have to have the probe.
Will the probe function? Will the probe function in space? What do you need for the probe to function? Huh? Some kind of.
No, it's
How does a thermometer work?
temperature radiation.
Material property.
Yes. So it actually gets in contact with
That's
air, right? For example, if you're looking at the room temperature, that there has to be convection to raise that temperature. So in space, this is a very big problem. If you launch a probe, there is nothing to contact. You understand? There is nothing to contact, and the probe will not get activated. So it's a very challenging thing to measure.
we cannot create a surface and then contact.
So that will be the surface temperature. That is not a, it may not be a good indication. Again, depending on what material you use, that temperature will be different.
Some modeling and correlation.
You have to do some modeling and correlation. So that is a challenge. The space temperature itself is very difficult to measure, but you can correlate. For example, have a host of different surfaces and measure the surface temperature. You can do that. So secondary mission objectives. What do you want to do as part of secondary mission objectives?
Camera.
Camera. What do you want to do on the camera?
Selfie for
Selfie. I don't want to suggest a selfie just because you need
selfie stick.
that stick. Yeah, that
Again,
mechanism. That mechanism will be.
So for that also we are trying to make it difficult because we have to measure the whether it is open or not.
Mhm.
Same thing will happen with the selfie also.
But the camera here, the camera can be on the surface of the satellite. Okay, that is easier. But if a stick is going to, if another deployable is going to come out, it's going to create another failure point. So we are not going to do selfie. Let's keep it simple. Static camera. The static camera, what do you want to do with it?
We'll take pictures of Earth.
Pictures of Earth from it. Okay.
Or SIT. The other
You better design something which is going to take SIT's picture, or you're not going to get your grade. Okay. He's very specific about that. Anybody who's in telecom and anybody who's taking his course, design something and give it to him. So first, secondary mission objective is take pictures of Earth and store it on board SIT satellite. So again, we cannot do this in one step, right? Store, then send it. So again, we'll have to take a picture and store it and then send it. Then think about it. Okay.
Sir, why are you named as PMO1 module?
Successful deployment.
Successful deployment.
Deploy. Yes.
Sir, is it solar rays enough to heat the temperature sensor and get the right?
It will again be solar array temperature.
But that's the only source of heat if you want to measure the temperature.
Yes. That is again not the. It depends on what material you use, what color you use. Alright. So what is the second this thing? Transmit. To store pictures along with GPS data and time ground station. Now keep in mind here you're going to, so you have to work on at least 2 systems. You realize? So you want a camera, now you have to work on a camera. You have to work on implementing a camera payload. This is your first payload, you have to work on this payload, and the second payload is a camera payload. Okay, so you have to work on these 2 payloads, and we have to figure out how to measure data, store it, and then transmit it. Got it? So these are the, we'll just limit to these, we'll keep it simple. We'll limit to these, this thing. Is that okay? You want more? No. Let's keep it simple. Now this is the first mission objective, and that is this is the second mission objective. Now how is the mission success criteria, what is it? So as long as these are successful, your mission is successful. If one of them fails, mission is a failure. You understand? If these pass or fail,
Partial.
if these fail, mission is successful. Okay, so that is how we look at it. If secondary mission objectives fail, the mission is still successful. If they pass, the mission is super successful. So these are your mission definition and mission objectives. So is this clear? We can work with this mission? Yes. Alright, so I think we can break for lunch. Come back at, what time do you guys want to come back? 2 o'clock.